In this video, we will discuss the angular equation, angular solution of the Schrodinger equation. So, first, angular equation. So, first, let me write the angular equation. So, it is y. Okay. In the previous video, already discussed how this equation comes. Here we will discuss about the solution. So for the solution, here again we will apply the separation of variable method. Okay, so for that, again here we will consider that y has a form of capital theta, and which is only function of theta, and phi, which is equation of phi, only a function of phi. So again we will plug this thing into the equation, and again dividing the whole equation by this, so we will get theta sin theta sin theta d phi d theta okay plus 1 phi e to phi d phi square equals to 0. So again it is only possible if these two part is equal to some same constant. So here we will consider the constant as m square. So first let us write the thing. So this have to be equals to m square, and so this will simplify, give minus m square. Good, very good. So first we will solve this part. Okay. So if we write this part equals to minus m square, so this will give simply d2 phi d phi square minus equals to minus m square phi, right? Just I simplify the equation. So for this solution is like of the form. So I am writing it plus I am. So also it is e to the power minus m phi also is solution, but for the time being we consider this only plus sign, and later on we will see that it is also possible for minus m bar. So fine. Okay, so already from the spherical polar coordinate configuration, you know that this phi azimuthal angle satisfy equation like this, that phi plus 2 pi, already you know it, right? Phi. Okay, something like so. After rotating 2 pi, we reach to the same point. So if this is the true, then you can write so I am phi plus 2 pi equals to exponential I m phi, right? So that gives 2 pi I m equals to 1. So the solution of this equation, actually, you know, already you know, if you do a little bit problem on complex number, it is clear to you that how it comes, right? So here you can see that we have got the equation, I mean solution for both minus m and plus m. Nice. So this is done. So now we will deal with the theta part. So let us write. Equals to 0. Okay, here I have written m. Fine. So this is actually standard equation of associated Legendre function. This is a standard equation. The solution actually looks like. So we will not solve the same polynomial. It is quite rigorous method, quite tedious. So just we will simplify the thing. Since the equation is same, we know we can recognize the equation. So we will put the solution directly. Simply. So this is the solution actually. This looks like. So actually now when the question comes, what is the form of this PLF? Yeah, that thing we can discuss here. That thing we can discuss. So we will not follow the whole complicated method. Just we will use the solutions. So, so PML is associated Legendre function. Okay, Legendre function. So how it defines? It is defined by it is function of a. If it is function of a, and in our case it is cos theta. Just we have to replace x as cos theta. Good. So this is dx. Now this is a Legendre polynomial. This is Legendre polynomial, and this can be found by simple Rodriguez formula. So by they are very standard. So I don't think you will face any problem understanding these polynomials. They are very standard. You will find them in any standard book. So this is defined as, I think this thing also you have done in second semester. These are all the things you have done. So at that time, at that moment, you thought that why should we know those methods? Why should you understand those equations? Now you can understand the application of those my functions or polynomials. Actually, they are used in different fields, and also I think you have read this application of these polynomials in electrodynamics too. So I will not write the polynomials. You can see all those things in very standard book. So I will not write. Just I can write the equation of this associated Legendre polynomial for your understanding. I can write as, okay, let us write for a simple part. There's 2 or 3. 1 PL, 1 is sin theta. Okay, so P01 is cos theta. Likewise, suppose P30. You will get those things in very standard way, every standard way. Cos 3 theta minus 3 cos theta. Fine. Now, so you got this equation, the solution. Also, you got solution. This is the solution for actually the radial part, one of the radial part. One of the angular part. This is theta part, and phi part already you got the solution. So you have to normalize all the things. So form of psi and y theta phi. After normalizing y theta phi, you will get this type of equation. You need not to solve these equations actually. You have to know only the results part. Just for one time you look at the solutions. It's 2l plus 1. It is not possible to remember all the things. First, try to remember. So it is. You can look at the equation. This is actually the phi part, and this is the theta part. Okay, so this is the normalization factor. So this is the equation actually for theta part. So it'll have to be non-negative integer to validate the Rodriguez function, and for m greater than L, all Pm should be 0. Okay, so it is what for associated Legendre function, and also for every L, possible m values are 12 plus 1.